Okay, we are live. Peter and Pete, welcome to the Terrain Theory Podcast.
Welcome. Thanks for having us.
Wonderful to have you both on here. Okay, who are you two? How do you know each other? And how did you get involved in the science that you're doing on your YouTube channel?
Well, we are actually brothers. We are twins. So we have a close connection there.
Yeah.
We ever since 2015, we created a YouTube channel where we initially started off on Flat Earth, of all things. We watched Mark Sargent's Flat Earth Clues and the penny dropped, and we thought, it all makes sense now. And because at the time, lots of people were going into Flat Earth, and we thought, well, we don't really want to go into Flat Earth. We want to learn more about the world we live in. So we decided to look at chemistry and look at the natural world.
Yeah, and you know, obviously we had a look at a lot of the scientific claims that are made, that science makes, and you know, we looked through them with very, how can I say, very sensible and rational eyes, you know, and we started to realise that a lot of the claims regarding the natural world they've got holes in, you know. So, you know, the more we researched, the more we dug up, the more we realized that science is very, very, what's the word?
Shaky.
It's very shaky. It's on a very shaky ground. And, you know, I mean, we've now reached a point where we both feel that a lot of scientific claims regarding the natural world haven't been proved. They cannot be proved to be true. And very little in science involves proof. And you know, you see that we're the type of people that if somebody told us they've got a fiver in their pocket, we'd like to see the fiver so that we know that they've got that in their pocket. We know they're telling us the truth. We know where we stand, etc., etc. But the thing with science is that because of the claims are just, you know, lack proof. We don't see that fiver, yeah.
Because one thing we've realised over the years, and that is, man has limitations. Man wants to put across to the masses that he's all knowing. He can do anything. He can know everything.
Yeah, man can.
Yet,
yeah.
From what we've discovered over the years, it's far from reality, far from the truth.
Because you see, I think a lot of people fail to, like Peter said, and man wants to project to the masses that man knows everything about the natural world. He can build pictures that are allegedly reality, you know. But at the end of the day, the way we see it is that human beings are limited in their capabilities. We're only human beings, and there's very little we can actually come to know truly about the world we live in. Very little indeed.
I mean, because you mentioned about the implications, so I don't want to go too far ahead, but one of the implications of all this is that man, especially people who are the elite and people who are up top, they want to be able to control people. They want to be able to have authority over people. And having knowledge is one way they can have authority over people. You know, we see it on our channel very often where someone comes in and communicates with us about using formula, F equals ma, and comes out with all these other formulas involving gravity, because that person thinks that he's got the authority to be better than us.
Oh, well, to have that knowledge.
By having that knowledge.
And he thinks he thinks because he's got that knowledge, he thinks it's true. Yeah. He has the authority.
Oh, yeah. So there's two strands to it. So having the authority, having that knowledge makes people think that they've got the authority.
Yeah, over others.
Which makes people think that they're better.
Absolutely, of course, yeah. My view is better than yours. You know, I think gravity holds everything to this spherical Earth. Okay, I can prove it with equations, and I can do this and I can do that. Okay, whereas where we're coming from is that no, you can't prove gravity. All your equations do is justify the idea of gravity, and that's all it does.
Yeah.
So, you know, this is the position that we essentially come from. And if you use that as your basis when you're looking at every single aspect of science with regard to the natural world and all of the claims that man makes,
or even in relation to the human body, for example.
Yeah, relation to the human body, or to the universe, or to what shape the earth is, or whatever, this is where you'll start to see that science lacks proof of even the simplest of claims that it makes.
And we noticed on one of your website that which detailed who you've interviewed over in the past. One of them was talking about scientism.
Scientism, yeah, sure.
I've forgotten the guy's name, but again, yeah, I mean, we can understand scientism in that it's a belief. It's a belief system when it's in relation to the natural world.
Obviously, because we're flat earthers, we can understand that the problems within science, and that one of the big problems in science is lack of proof, which means promoters of science have to believe that the science is true. They've got to believe. They can't know that it's true because they've got no proof. They can only believe it to be true. This is why it's very common for people to say to you, well, I believe the earth to be spherical or round, you know, or I believe water's H2O, or I believe we went to the moon, or I believe this, or I believe that. And yet all of these they're supposed to be facts where the belief shouldn't come into it at all.
Yeah.
But you know, so we've identified the limitations that we feel present within man's capabilities in his study of the natural world.
Yeah, so that's more or less us over the past 7 years.
Yeah, that's basically what we've been doing over the past 7 years.
We've done lots of demonstrations because we're very practical people, pragmatic. We like doing things.
Yeah, absolutely, of course.
So you know, we do electrolysis. We burn things. We make things. You know.
Oh, absolutely, of course.
Understand.
Yeah,
you know.
Yeah, because I suppose we feel that we're the type of people that it's okay having a YouTube channel and sitting in front of the camera and the microphone, and you're telling your viewers your view that you've got. But you know, we're the type of people that if we don't have anything to support that view, you know, we think, well, what's the point of doing it? So that's why we prefer to do demonstrations. We do some electrolysis at home. You know, we do quite an awful lot, don't we? In order just to support our views and opinions, you know.
So there we go.
Yeah, that's us.
There's a quote that I came across actually this morning that I felt was relevant to this conversation. Scientific knowledge is a body of statements of varying degrees of certainty, some most unsure, some nearly sure, but none absolutely certain. And I think we're at
You've hit the nail on the head. Well, with that quote, it reflects exactly what we've been what we've been saying in our videos. You know, science has its limitations. Human beings have their limitations,
and a lot of that is also because the imagination is limited. Man can only think of so much. They can't think beyond. They can't think metaphysically. They're stuck to the physical world. So man will do something on Earth, and his understanding of that, he'll apply that understanding to the universe.
Yeah.
Even though what he's doing on Earth isn't the universe.
Yeah. So, for example, give the viewers an example there.
Well, as an example, he uses like Fraunhofer lines. Fraunhofer lines is associated with a spectrometer.
Yeah, that's right.
And he uses that to understand the constituents of matter. For example, man can burn a gas, for example, and it will produce a certain light. And he puts that light in front of the spectrometer.
Yeah.
And he'll look at the spectrum of that light through his spectrometer. And then he might find that if he looks up at a star, he might get the same spectrum.
Oh, that's right. Yeah, sure.
from the looking at the star from that light
by looking at it through a telescope kind of thing.
Basically.
Sure. And then he'll think, oh look, it's similar, it's the same. Well, that planet or that star must contain this element.
Yeah.
Helium. Helium or whatever. And and yet you think to yourself, but okay, well, it's a hypothesis, it's an idea. Okay, it's a good idea that you've just discovered through doing your observation and your spectral lines and stuff. But what are you going to do to test that hypothesis? That idea that you've got helium as part of the sun, for example.
Yeah. How are you going to be certain?
Yeah, how are you going to be certain? And this is the limitation of science. It runs throughout many disciplines of scientific inquiry.
Yeah, because there's one difference between looking at a flame through a spectrometer, like in a laboratory, and looking at the sun, for example, because you've got the atmosphere between the sun and you.
Yeah.
Whereas in your laboratory, there's no atmosphere.
Well, yeah, but I suppose the main thing there is that nobody can go to the sun to actually show or demonstrate that helium exists.
Absolutely.
Now, this is the big problem. I mean, like, for example, science is limited. For example, we could also look at electrolysis. We'll get onto this, I'm sure, later, but electrolysis is a very simple method in order to, as science would say, split water. So you've got two electrodes in a solution, okay? So cathode, anode, positive and negative. And people will say that the water's being split into hydrogen and oxygen, yeah? But when you actually do look at the process, does the process actually demonstrate the water's being split? This is the problem. All you're seeing is the electrodes will eject these bubbles of gas, but that doesn't prove where the water's being split, does it?
No.
All it proves is that what you're basically seeing, what you're observing, and that is the electrodes are emitting these bubbles.
You've affected a physical reaction within the matter, and that's about it. That's all that you've demonstrated.
Sure. But I think it's wrong for science or for anyone to just apply what he thinks to other things in the rest of the world when it's something he can't know.
Yeah.
I think that was quite a good note.
Yeah, and I just so I want to just interject really quickly so that the audience understands, and I hope that those listening go to the YouTube channel to understand exactly what aspects of science you are questioning, because we're not talking about like, do carbohydrates make you fat or some of the you're going to some fundamental foundational assumptions, like, for example, what is water made of? You've looked at and explored, challenged the notion that we've all been raised on, that water conducts electricity. I mean, you're really going after some sort of foundational fundamental, what many listening would think of as truths, scientific truths, and you've said, well, actually, we just don't have the evidence. And what I respect about this, and we're going to come back to the question, what is water? What I respect about what you're doing is it is very similar to what we see people in this health space, specifically the terrain theory space or terrain model space, doing around the question, what makes us ill? And looking at the germ theory paradigm and saying, actually, let's take a look at the evidence for this pathogenic virus causes this illness. X pathogenic virus causes Y illness. Let's just look at the body of evidence that's been used to support that argument, and found it severely wanting, found it lacking, and therefore have stepped back and gone, well, we're going to label virology as pseudoscience because they're not adhering to the scientific method. That's all to say, the questions that you're asking, or at least the approach that you're taking to putting all of these, not all of, but so many foundational truths under your microscope, literally and figuratively, is not foreign to us. And in fact, Mike and I mean, I'm tickled by some of the topics that you get into on your YouTube channel. One of them being like the exploration of water, because we've had a number of folks on this podcast who talk about water, structured water. You went after easy water or exclusion zone water. Yeah. I see the nodding, and I saw that, and I go, oh, well, okay, they're really they're going after that we've been talking about structured water. We've talked about easy water. We've had folks on, saying that the body is 99.9% water molecularly. So now we've got to step back from what we've been talking about on this podcast and go, okay, fellas, what is water? Why were you inspired to challenge the very composition of water? Let's start there.
Well, because well, to be fair, I mean, I think that as we went through the years of doing our YouTube channel, we touched on the electrolysis.
Yeah,
we touched on the electrolysis, and we realised that the actual evidence that they used to promote only the idea of water splitting hydrogen and oxygen, the information regarding electrolysis just didn't work. To us, it just wasn't right. And I think we just followed straight away with that, because we just identified it quite easily and readily.
Yeah, I mean, you've probably heard of colloidal silver.
Mm-hmm.
And that in many respects, that's exactly the same as an electrolytic process.
Yeah, absolutely. Yeah,
all you're doing is you're decomposing
the anode.
Sure. That's all you're doing.
So your silver anode will decompose, and it will just and all the impurities of that silver will just float around in the solution.
Yeah. If you let the electrolytic process run for so long, you'll get so many impurities within the water, and then after a while, 10 minutes, say, you can get your water, pour it into a glass, and then drink it, because you think, or someone's told you, that it's healthy for you.
Sure,
it's good for you. It's exactly the same with magnesium. When people put magnesium,
yeah, sure.
They do exactly the same with magnesium
for hydrogen water.
It's very similar. How people think that water's made of hydrogen and oxygen.
So, yeah, I mean,
and the hydrogen is good for you.
So, but returning to the point, I mean, I suppose because I'll always remember the Wikipedia page on the electrolysis water, they call it. And it's a very simple setup, and you can straight away see the flaws in it, especially if you carry out electrolysis yourself. As soon as you start doing it, you don't need a lot of money, you don't need a lot of space. Yeah. It's very cheap to do, it's very easy to do, and you can just do it yourself and start thinking, there's something not quite right here. And one of the easiest things to identify is the fact that you can't know whether the water's being split.
Yeah.
Only because you see bubbles being emitted from each electrode. And how does that prove or even demonstrate water's being split?
And water's made of hydrogen and oxygen.
And water's made of hydrogen and oxygen. And, so we went from the electrolytic process and to uncover an awful lot of information regarding water being H2O. There's an awful lot of information supporting the idea that water's hydrogen and oxygen. Awful lot of it. Yeah. So we ended up writing the book, didn't we?
Yeah, which is 100 Reasons Water's Not H2O. I mean, the whole modern day chemistry is built around the understanding that water is made of hydrogen and oxygen.
Yeah,
but we have to go back in time to understand why this actually came about. Because we're talking like 250 years ago. In
the 1700s,
late 1700s, you had a guy called Lavoisier who wanted to change the current thinking at the time.
Yeah,
because at the current thinking at the time, you had your classical elements: air, water. Water was an element in its own right. Earth, fire.
Earth, fire, yeah, sure.
And modern chemists at the time wanted to move away from that, so they had to find a way, because it's all part of developing his world, not the natural world, because water will remain the same whether it's 250 years ago or 2000 years ago. Water was always the same,
and it always will be. Water, water fundamentally won't change throughout all of human life.
But man wants to show that he's developing, going back to authority, going back to having the power, the knowledge. He wants to show that he's developing as a species, basically. So he wanted to destroy the four elements,
the four classical elements,
and create something new. And this is where it was born that water was made of hydrogen and oxygen.
Yeah, Lavoisier steps in.
We've got a document we can share with people, because it's in relation to water. Your question of what is water? One on Richard Kerwin.
This one.
Richard Kerwin.
This one here.
Yeah, you just have to bear with us to get
the right page.
Because there's a number of, because Richard Kerwin at the time in the 1700s, he was a phlogistonist. So he was
a supporter of the current theory. The current theory at the time that was predominant.
Yeah, basically.
Dominant, the dominant theory.
So I'm sure it's either not 6 or 27. It's been 28.
28. Well, we're going
to bear with. But Richard Kerwin challenged Lavoisier. There's things that he just did not agree with. And one of the things that he didn't agree with was that water was made of hydrogen and oxygen.
28.
Just
30.
28, bottom.
28, there we go. So
no, that's vitriolic acid, sorry.
What? No, not that one.
Well, I've got 6, 27, 28.
Oh, hold on.
So we've got lots of information. So it's just
introduction on number 6. Here we go. 6. Metal proceeds from the decomposition of water.
About the metal, the hydrogen coming from the metal.
Yeah, sure. Yeah, of course.
Well, we can stick on that. Let's go for.
Let's start with this.
We don't lose people. Here we go.
So there.
So this is Kerwin and what he was critical of Lavoisier's theory.
Well, one aspect of it.
Yeah. See, Lavoisier said that when you react to metal with an acid, the hydrogen comes from the water.
Yeah. So this is
a fundamental understanding of modern day chemistry. Kerwin at the time put forward the view that the hydrogen, or the inflammable air, as we would call it,
during the solution
of a metal proceeds from the decomposition of water, or from the decomposition of the metal.
Oh, sorry, yeah.
So he's recognising there that it's either from the water or from the metal.
Yeah.
For the metals that principally afford it, as iron and zinc, are by themselves and in total absence of water, perfectly inflammable, and therefore should be deemed to possess the same principle for inflammability as vegetable and animal substances, is attributed to the preference of inflammable air, whereas water can be inflamed in no circumstances whatsoever. You can't burn water.
It's a clear example that I'm sure we cover it in our book as well, that water, you put water to extinguish a fire. You put water on flames to extinguish it, so you can't burn water. And, so how is it possible that hydrogen can come from water, especially when it's bonded with oxygen? Oxygen's supposed to be something that supports combustion, it's a good idea. H2O is a good idea, but we'd like to see some proof, and we just don't see any. And we're not the only ones. Obviously from Richard Kerwin's information, even he doubted Lavoisier's assertions regarding water to be H2O, or where the hydrogen was coming from.
Yeah. I mean, here it says another principle assumed by the patrons of the new theory. This is Lavoisier's theory, and which indeed is a cornerstone of their whole system, which is the decomposition of water into hydrogen and oxygen, but of which the maintainers, which is Kerwin and other people like James Watt, of the old doctrine, have as yet received no satisfactory proof.
Yeah.
And this is going back to your word certainty. They've received no certainty.
Yeah. So if we go,
water should be decomposed by charcoal, at least in boiling heat. In other words, Kerwin's saying that you should be able to decompose water by other means to be able to release the oxygen and hydrogen.
Absolutely, of course.
But you can't.
If we go on to this diagram, we can actually talk about this, can't we?
And actually, let me just stop you really quick, because what I see that you've done is you've said, okay, where is this? Where is the basis in history for this idea that water is H2O? And what you've done is you've gone back to, say, the very beginnings of this. Where did this theory originate? What was the process used to support this, this theory, and found it wanting? And not only that, but you found contemporaries at the time also found that to be wanting, which to me seems pretty reasonable and a reasonable first step. So continue. Or actually, am I anywhere close to being correct?
No, you're right, because that's the best way to do something, and that is you've got to understand how these ideas came about in order to realize that they're only ideas, or they lack certainty, as you say. But returning back to the idea that hydrogen is contained in water from Lavoisier all those many years ago. In the diagram here, we've got Lavoisier. Obviously, that's him pictured, but he's got his apparatus there. So he's got on the right, he's got a glass retort. There you go. Wait, I'll just maximize. So he's got a glass retort there on his burning stove. I'm going that way. That's it. So he's got a glass retort being heated. It's got water inside it. So the water's been turned to steam. The water then passes through passes through an iron pipe, which is encased in a small furnace, and so it's red hot. So obviously you're going to produce superheated steam inside that pipe, and then outside the steam, superheated steam is then cooled. It's condensed. And in J, we see a reservoir which collects all of the condensed water. And from into K, then goes the gas, which is hydrogen. Okay. Now, you've got two kind of positions on this single demonstration. And one position is current mainstream science's understanding. And that is what's happening is the water's being split. Okay, the steam, water turns to steam, the steam passes the iron pipe, the oxygen of the water is reacting with the iron pipe to produce rust, iron oxide, and the hydrogen is continuing on to be collected in the glass vessel K. So that's mainstream science's interpretation of what's happening. Now, our interpretation of what's happening is that the water's being heated, it turns to steam. The water goes through the iron pipe, the red hot iron pipe, and decomposes the iron pipe to release the hydrogen. The hydrogen then passes along the rest of the pipe work.
Along with the
steam. The steam condenses, turns into water, and the hydrogen is collected in K. The hydrogen from the iron pipe. Yeah. So, it's clear that everyone can see that. That there are two conflicting views on this demonstration.
Someone would ask,
and they're both valid.
Yeah.
Essentially,
someone would ask, but what about, in your understanding, what about the oxygen?
What about the oxygen?
No, I'm just asking you.
Well,
you were talking about the hydrogen.
Oh, sure, yeah.
What about the oxygen?
Well, you've got to be able to collect it in order to know that it's there.
So the idea in mainstream is that the iron pipe turns to iron oxide because it's reacting with the oxygen.
Sure.
But then you've got to show that there is oxygen in iron oxide.
Yeah.
So that you know that it's there. It's there.
It's present. Yeah.
Because all you're seeing is the decomposition, the rusting of the inside of the pipe.
Yeah. So
that's all you see.
Yeah. So from our point of view, I'm going to have to reiterate this.
We could put forward the view that it's not producing any oxygen at all.
Yeah, absolutely, of course. So essentially, in our view, the water turns to steam, and with the aid of the heat, decomposes the iron pipe to release hydrogen.
Yeah.
And water, the excess water, obviously, is carried on through and condenses into J.
Yeah.
And so there again, you've still got no proof that water is made of hydrogen and oxygen, and yet science will show this as evidence that water is made of hydrogen and oxygen.
Yeah.
You know.
Well,
Job there,
no, yeah, that was well done, and the alternative explanation seems just as reasonable to the layperson.
Yeah, absolutely. Yeah, sure.
But the question is proving. You can't prove either way.
Yeah, you got. Yeah, sure.
You can't prove
we can probably. I mean, we've done quite a lot of. We've uncovered a lot of information that where people will try and prove that water is made of hydrogen and oxygen. Like, for example, if they were to ignite hydrogen in air, you'll get a dew form. So if you had hydrogen in a test tube and you put in a lit splint and you get that squeaky pop, you'll notice a dew form within the test tube. So they say, well, it's oxygen in the air, reacts with the hydrogen to form water, and the water's in the test tube. But you see, the thing is that there's so many other variables that can affect the result on that demonstration. For example, water can migrate as a gas along with hydrogen. Okay, so the hydrogen that's collected in the test tube may actually contain gaseous water to begin with. There's also water vapor in the room that you're holding the test tube and you're inserting the flame. We've got all of these other variables that can account or can explain for the presence of that water than the hydrogen reacting with oxygen to create water, to form water.
Even this demonstration here by Lavoisier clearly shows that water is migrating along with the hydrogen.
Yeah, I mean, we've
clearly demonstrated.
Yeah, I mean, brings on to a good point we made in our book, and that is water cannot be destroyed, created. It can only change from one form to another. So you've got water as liquid, solid ice, and gaseous water. So it can only change between those mediums. You can't destroy it. You can't create it. So when we look at Lavoisier in this demonstration, the water that's in the retort on the right-hand side will just change as it passes through. It will migrate, as it goes through the system.
Although some of it will be absorbed by
the iron. Yeah, the iron pipe will absorb some of the water, obviously, because that's it's going to form. I mean, that's one of the reasons why we think iron rusts is because of moisture.
Yes, moisture.
Though we think it's moisture, we don't feel that it's oxygen in the air.
Got it. And to be clear, and so again, to be clear for myself and also for the listener, you're not arguing, or are you, at the existence of the element oxygen or the element hydrogen. You're just saying that water is not comprising hydrogen and oxygen.
Well, to answer that particular question, I mean, we've looked at the periodic table of elements, and we've actually read up a lot about each element. We've actually made some of the elements, and we've come to the conclusion that they're all it's a periodic table of products.
Yeah, apart from hydrogen.
Apart from hydrogen, a lot of the products, it's like aluminium. Aluminium is a good example. A lot of people would say aluminium is an element. It's an element. It's in its own right. It's a metallic material. Blah 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 blah. A lot of people think it's only made of aluminium and nothing else. But in fact, if you think about how it's made, how man processes the ores and the materials involved, it's made up of sodium. It's made up of
fluoride,
carbon. It's made up of fluoride. It's got other elements within it. So in our understanding, it's a product.
Yeah.
It's not an element.
Yeah, we do tend to think that.
And it's the same with oxygen as well. Oxygen, you can't find, in our understanding, there's oxygen comes about as a result of a process. You have to process air in order to make oxygen.
And without that processing, you've got no oxygen.
So we would agree that there is oxygen. Oxygen does exist.
Yeah.
Hydrogen does exist.
Yeah, all the elements on the periodic table exist, but whether they exist naturally, now that's a different question. You know, a lot of them, in our view, in our opinion, all of them, sorry, bar hydrogen, are all man-made. They're all artificially made.
Without the processing, there's no aluminium.
Yeah, there's no iron.
Okay, let's go back to the original question then. If what is water? So if water is not H2O.
Well, I'll answer the question. Is if you want us to give you an answer as to what water is, couldn't tell you.
Yeah, we couldn't tell you what water is.
I don't know whether you've seen Neil deGrasse Tyson being interviewed on was it Joe Rogan show where he's asked what is gravity. I don't know whether you've seen that.
I haven't.
No,
sorry,
I have not seen it.
Oh, right.
Well, he doesn't actually say what gravity is.
Yeah.
He says things like, well, we can measure it, we can describe it, we can do this with it,
we can do that with it. But what it is, well, we just don't know. And that can be applied to water. I mean, I think, yeah, that can be applied to water. I mean, we could call it an element. We could call it an element,
yeah,
you know. But that would be describing it.
We can say that it's a medium. It's a medium to allow things to move about in. Whether it's a fish, whether it's a ship, whether it's a submarine. An impurity.
Or it's a medium that can be a medium that can be filled with impurities.
Like your water in your body. It allows things to move around in your body, to flow. In your body.
Yeah. So, yeah, I mean, it's very. See, the thing is that, you know, we're not. What's the word? We don't really feel that we're defeatist as such, but you know, it's very difficult for us as like mere human beings to come up with this kind of like knowledge about what things are, like water, for example. When, you know, how are we going to attain that knowledge? How are we going to actually know what water is?
Yeah.
How we can do things with it, obviously, you know, and we can describe its properties and all this lot. But what it is, you know, actually saying what it is, you need to be on a different level, you know. Yeah, and I don't feel that I don't think human beings, especially in 2023, have even got the capabilities to be able to work that one out.
Well, even they've never got.
Well, they may never have, you know.
Capability, because the thing is that it's all about understanding the world we live in, and we're born into this world.
Yeah,
we never made it, did we?
Yeah, I mean,
we never made the water, we never made the rocks, the earth, the sky. We never made that. It was there when we were born into it.
So coming to know what things are around us, you know, it's, you know,
it's a bit like it reminds me of the guy who said to draw energy for me on a piece of paper.
Oh, right, yeah.
I mean, draw energy. How would you do it?
Yeah, what do you draw? Power station?
That's not energy. That's the power station.
Yeah, I know. Yeah,
we would. Mike and I would do a lightning bolt probably, but
oh, right, yeah. Actually, I had that in my mind. Actually, a lightning bolt. But you get the point, though. That, you know, the point is that you know, I mean, there's only so far that we can actually go to actually come to know the real world that we live. You know?
I want to get you.
That's what we think. Anyway,
I want to get you two back on the screen.
Wrong, you know.
We've got the experiment. I just want to make sure I'm getting the face to face. So if we could get back to you two on the screen.
Oh, quick. Sorry, right.
Yeah, no, that's okay. That's okay. I just I miss seeing you two is what it comes down to.
Oh, right, yeah.
We've only just met. There we go.
Now, yeah,
there we go.
Sorry about that, but
no, that's I think. Well, okay. So I think. Oh, Michael, go ahead. Do you have a question?
I was going to say, while we're on the thread of things you can't know, do you have any thoughts? Would you consider ether a classical element? Do you have thoughts of whatever this thing ether is or might be?
We were. I can remember me being asked. I responded to a comment about the ether, and you know, I get to thinking, but what do people actually mean by that word? You know, I mean, I'm familiar with it. I've heard it. The ether.
I suppose it would be
the air.
I suppose the ether would be a good word to use instead of atmosphere.
Yeah, ether would be a better word
If
to use.
you know, being a flat earther.
Yeah,
You can't
sure.
use the word atmosphere
Yeah.
if you're a flat earther.
Yeah, we can't. Yeah, we can't. We're banned from using the word
because of the vacuum.
Well,
no, because of the sphere.
Oh, I understand. Thank you.
Atmosphere.
Yeah. Okay.
Yeah,
Never
we've
thought
got
of
very
that.
sensitive YouTube viewers, haven't we?
Yeah, so ether would be a good word to.
But yeah, sure.
But
Well, they also call it it's the word quintessence, right? The fifth essence, the fifth element in some sense.
Yeah. Yeah, but the thing is, neither of those words do anything for me.
Sure.
They don't.
They conjure up.
They conjure up something that I don't feel is tangible.
Oh, well, it's
I can't get to grips with.
It's kind of out of this world and beyond.
Sure.
Well, similar to what you said about water, you couldn't tell us. There are things perhaps we can't know, and I don't know if I necessarily want to derail the conversation into this direction, but it's come up several times with past guests, this idea of spirituality and science, and that some people make the claim that when those two things were divorced is where all hell broke loose. Do you have any take on where spirituality and science meet up again or belong together? Do they belong together? How do you approach that?
Yeah, are you referring to spirituality as in like believing in a god?
That certainly would be part of it, and I think this question about ether is wrapped up in it as well. I mean, we could go straight up, like, what are your thoughts on where did creation come from? Like, however you want to approach it, go nuts.
Well, I personally think that you had a lot of people many years ago, because religion was all that people had many years ago. They didn't have materialism, they didn't have mobile phones and cameras and the internet. Religion was all they had, and religion had quite a strong hold on people. A lot of people didn't like religion, they didn't want it. They had no choice, just like we're living in the UK and we have no choice that we have a monarch. But that's the way
or we live in a globe society.
Yeah.
But
that's the way it is. So these people, Copernicus, lots of other people,
Newton,
wanted to come away from religion, wanted to break free and create their own kind of religion.
Yeah, because
something that they could believe in, something that they could control, something they could love and cherish and nurture.
Yeah. Oh, yeah. So I suppose any way you can get science and kind of like spirituality, in the sense that spirituality is kind of religious and kind of together, is when science actually admits that it is a religion in itself, and it is no different to spirituality.
Yeah,
because you have to believe in science in order for you to get on with it.
Yeah, because there are some parallels between science and religion. For example, one of the things that they touch on is like in quantum mechanics, they talk about what's that thing where you have two people can experience
quantum entanglement.
Quantum entanglement.
Absolutely, of course.
I don't know if you've come across that term.
Of course.
But it's just a situation where two people can experience the same thing, and they could be miles apart from each other. And it's interesting how, like, modern day science is trying to figure out
emulate
that kind of experience.
Yeah,
that is only understood, or really understood, in a spiritual kind of way.
Oh, so what somebody could argue is that science itself is a kind of spirituality, because it does try to explain the life experience of human beings.
Well, yeah,
it does try to explain,
but it only use its own lingo, its own
codes, and
if you don't understand those codes, then
you probably think it's total rubbish. But
it uses its own language and its own storytelling to try and
basically, sure.
Because the thing is, with man's society, any civilization, it's all tribal. You're either in that club, or you're in that club, or you're in that club, or you're in that club over there. But you can't be in all clubs.
That's yeah.
But it's just an understanding the science is a way to, it does. I think there are parallels between modern day science and spirituality. Yes.
Well, there are two ways of that man has found to try to answer the questions that perhaps are unanswerable. I mean, it's really coming up back to what you said was there's a limitation to what we can know, and yet man has this maybe eternal curiosity, or as you said, a desire to have that answer because that knowledge is power, and we'll just continue. We'll decide on a thing, claim the authority to call a thing a truth, and then start to build on that, and just build and build and build. And
Yeah,
sorry.
an idea, not a truth.
Yeah, thank you. Well, yes, they would claim, yes, I would say they would claim it to be the truth, and this is the foundation. But what you're saying is it's really just an idea.
Yeah.
Well, the idea, that phrase "knowledge is power" can be inverted. You can fake the knowledge in order to claim the power.
Yeah, well, yeah, absolutely.
Yeah, sure. Yeah, because people, well, when you look at, when you do look at people, people can be easily manipulated. You can get people to do lots of things if you've got the right tools and equipment. So why not? If you can do it, there's nothing stopping you.
Yeah, but it's all about intent and what the outcome is.
Oh, sure, yeah, of course.
Yeah. The outcome is a detriment to people or not.
Sure.
But should we? I want to, because we've got quite a bit to get on, and I want to get on about what we exhale, and
let's get back to that.
You do ask about water does not conduct electricity.
Well, let's go back to, okay, what is it that we exhale, and more importantly, what do we not exhale? That's a leading question. I think you have the answer, because we've had folks on this show who are, breathing experts, breathing coaches, and they talk specifically about carbon dioxide and all the mechanisms and functions. Yeah, look at you, covered your mouth. Go on, let's get into this. that which shall not be named, please. What is it that we exhale, and what do we not exhale?
Well, we got some interesting videos to show you guys to help you understand where we're coming from.
Yeah, sure. Because a lot of people, obviously, some people might hear our views straight away and probably think, we're mad. But as soon as we start showing people some of the things we've done, they'll soon start changing their minds, and then they'll start questioning. Oh, okay, blah, blah.
Now we have to remember carbon dioxide, according to mainstream, is 1 part carbon, 2 parts oxygen.
Yeah, carbon, we don't need that one, do we?
Carbon is mainly brought about through
combustion. Yeah,
you burn something. Yeah. You burn wood. You burn paper. You burn coal. You burn
gas.
You burn whatever. You will produce carbon.
You'll produce carbon.
So, does the human body burn anything?
Well, I would say I'm not on fire, but I don't know all the intricacies of the.
Oh yeah, you're not on fire.
Listen. When I get on a roll on this podcast, people would say I'm on fire. But
I know you used the word carbohydrate earlier.
Correct.
That word carbohydrate. Again, in our understanding, people think that a food contains, the human body burns the food.
Mm-hmm.
That's why they call it a carbohydrate.
Right.
Yeah, I think so. Yeah, sure.
But in our understanding, because it's all about how we understand.
Yeah, it's
the body and the natural world. In our understanding, the food has just undergone a carbohydration process.
So it's been carbonized, and it's been exposed to water, hydrated.
So it's been exposed to smoke. And water.
So, for example, sugar, I believe, I understand to be a carbohydrate, sugar.
Yeah.
So sugar, if you look at the way sugar's manufactured, they do actually add some kind of carbonatation process, and it's obviously been hydrated throughout the whole of the process, really, the sugar beet or the sugar cane. So, the sugar is the carbohydrate simply because of the processing it's been through. or it's undergone. So what that does to the body, is
Yeah, but the point is that there's no combustion in the human body.
Yeah, we don't. Well, we don't think there's any. Well, we don't see any furnaces or anything like this in the human body. I think we'd all feel it. If our cells were on fire, we'd all feel the
But
heat.
Anyway, one of the things they use in a submarine is called monoethanolamine, which is used as a scrubber in a submarine. I think you did mention this. So what we thought we'd do is we thought we would get some of this and we'd actually blow through it, because science tells us, mainstream science tells us, that we exhale carbon dioxide.
Mm-hmm.
So we expect that the monoethanolamine will be able to capture this CO2.
This alleged CO2. Absolutely, of course. So we're pouring some in the Erlenmeyer there.
We won't play the whole video. We'll just skim through it.
Yeah, I wish I could get up the. I've got to remember where to go.
So we've put the monoethanolamine in an Erlenmeyer.
Mm-hmm.
We're going to blow through the monoethanolamine, and then we've got an Erlenmeyer side outlet, which is got a pipe attached to it, which is going into this jar, which has got the flame. So is our breath going to still put out the flame?
No, because obviously carbon dioxide is said to be a gas that doesn't support combustion, so the flame should go out if you exposed it to CO2. So what we should see here, I blow through the glass.
You need to move it forward, because we
had to put some more in right there. Just got to add some more. There we go. So we put the sponge on the end just to separate all of the diffuse the air, exhaled breath. And will the flame go out? The flame should go out, shouldn't it? Really?
Oh yeah.
No, it shouldn't. No, it should remain lit, because the monoethanolamine is absorbing all the CO2.
Mm-hmm.
That's what we're told. That's what science tells us. So essentially, the flame should remain lit.
Yeah.
Because there's no carbon dioxide in the exhaled breath to put out the flame.
Mm-hmm.
So we do this for quite some time, and as you can see, the flame's still lit.
Well, move it forward.
Let's move it forward. So I don't know what we get up to there. We're not doing much there.
These kinds of demonstrations we can.
I don't think it actually went out. What were we doing there? Oh, we put. Well, wait there. Let's go back a bit. Why can't I get? What I want is to get up the. How do I get up the? How do I get up the didgeridoo? Right there. So, anyway, the flame doesn't go out. Oh, it's nearly there. Oh no! Oh, it does. No. Oh, it did go out. Oh, it did go out. Oh, it did go out.
Yeah, but it shouldn't go out.
Oh, but it shouldn't go out. It shouldn't go out, but it's gone out. Yeah, sorry. Yeah, I'm getting confused here because I'm having to flip through all of this video.
Yeah. So the flame's gone out.
The flame's gone out.
So what we do is we use our oxygen sensor to determine the reduction of alleged oxygen in that jar.
In that jar. That's what we do. Yeah. Sorry about that. Yeah, it's quite difficult when you're trying to zip through a video that you've watched like 2 months ago. But yeah, so we got our oxygen sensor in the jar, and we stick the pipe in right there. I want to be able to use that. Oh, there you go. That's it. I've got the thing. So there we go. I'm blowing through it. That's it. Yeah, I need to put the pipe in the jar. I know, right there. There we go. There's the pipes in the jar. There we go. So it goes down to 6. We've got it down to 16.3. So obviously it's calibrated to give you a reading in air of 20.9. But it gives it. We use the oximeter, the oxygen sensor, just as an indication on the air that's contained in certain vessels like this glass jar at the moment.
But we can clearly see that there's a reduction, which would explain why
the flame went out.
So we can safely say that the monoethanolamine does not absorb anything that's in the breath that extinguishes the flame.
The monoethanolamine will not absorb any material that won't support combustion or life.
Mm.
So because it's clear from this demonstration that there's the flame went out. We've got a reduction on the oxygen sensor, which shows that we're still getting an airstream coming out of that's been passed through the monoethanolamine, that it still won't support combustion and won't support life.
Yeah. So there you go. Let's move it forward. I don't know whether you're
on this video.
No,
on the next one. Yeah. So the next one.
Okay.
I don't know whether you're aware of the lime water test. Are you aware of lime water test?
No, I am not.
Well,
right, I think
it might be an idea to get a video up on the lime water.
Let's go up here. Let's just show you the lime water test. Now,
it's all about demonstrating that we exhale carbon dioxide.
Now, if you go to school, you'll be shown this demonstration, or you'll undertake this demonstration, and you basically it's there to convince people that you exhale CO2. That's all it's there for.
Yeah.
Okay. So let's just maximize this. So I'll just switch the volume down. So in here, so you've got CO, you've got lime water, okay, which is calcium hydroxide, okay, and you've got carbon dioxide being pumped into the pipe. And what happens is that after a while, the lime water will go cloudy. So if I just speed this up a bit or move forward on the video, there we go. You can see that it's going cloudy or milky. So what they get students to do in schools is they get them to exhale their breath through a straw into a test tube of calcium hydroxide lime water, and essentially it will go from clear to cloudy after a while. Okay, so that's the lime water test, and they say that you exhale CO2. Okay, yeah. So we're on here, aren't we?
Yeah.
So now we've got diammonium hydrogen phosphate, which is a salt. Okay, and we're going to see what other instances will lime water turn milky.
Okay. Yeah.
Essentially, because we just don't feel that the lime water test is satisfactory in determining that we exhale CO2.
Yeah.
Because you can get a furnace, you can get a candle flame, and you can collect the gas from the candle flame, bubble it through lime water, and it will go cloudy as well. Okay.
You could burn a diamond.
You could burn a diamond, and that also, and you pass the gas through lime water, and that will turn milky as well. So we're thinking, but those involve combustion, don't they?
Mm.
Right. Whereas our exhale breath, well, where's the combustion?
Right.
Yeah, there's no combustion. So how can we exhale CO2? There's got to be another reason to explain the observation of lime water going milky.
Yeah. So you're going to get the straw now, and you're going to, or a pen, and actually blow through that into the lime water. This is what they do at school.
Yeah.
And you blow through this solution.
Blow through the lime water.
And it would turn milky.
Lime water turns milky, as you can see.
There you go. Hold on.
There you go. There you go.
Gone, see that? Yeah.
Yep.
Gone milky. I'm just going to see if I can find. Oh no, wrong one.
People will say because that's gone milky, that indicates the presence of carbon dioxide.
Okay.
Yeah, I just want to. Oh, there you go. I've got it there. So what we're going to do is we're going to add diammonium hydrogen phosphate to some lime water to see what happens. Okay. And wait there, we've got it. Put some on a bit of paper. We did this a long time ago. Really, if we'd have carried it out maybe a week ago, we would have just poured it straight into the test tube.
Yeah.
But
just move it forward.
So there we go. We don't need. I'm drinking the water for some reason. Yeah, there we go. So what are we going to do there? Oh, there you go.
Oh, you're going to put some in water.
Put some in water, which is this, and then I'm going to put some in lime water just to show the difference, because you need to know that you need to do these things in order to find out. So the diammonium hydrogen phosphate just being added to water, will it go cloudy? We don't know. And when I get it there, let's speed this up.
Yeah.
Go forward a bit, shake it up, and no, it doesn't. Nothing there at all. It doesn't go cloudy at all. There you go. Okay, so that's the diammonium hydrogen phosphate in water. So let's try the diammonium hydrogen phosphate in lime water. Let's add it to lime water. Let's see what happens. Okay, so I'll just zip through this. And the big question is, will it turn milky? Okay, and remember, it's a salt. You've always got to remember that carbon dioxide is an acid gas, and lo and behold, it's gone milky already. So the diammonium hydrogen phosphate has turned lime water milky. Just by adding that to the lime water has turned it milky.
And we've done the same with smelling salts as well.
We've done the same with smelling salts, which are ammonia based, and it's also turned it milky. Yeah, that's me, because I think we did quite well on that one. But you see, the thing is that, like I've said, carbon dioxide is supposed to be an acid gas. And one thing that we have discovered through our research, and that is an acid neutralizes cloudy lime water. So if we were to, in this test tube now, if we were to add an acid to cloudy lime water, okay, it will turn it clear. So how can carbon dioxide, an acid gas, turn lime water cloudy? It doesn't make sense at all, does it?
Yeah, so we've come to the conclusion that it's a salt. It's only a salt that turns lime water milky.
Yeah, there's something else happening when you see the lime water test and people blowing into a test tube of lime water and it turning cloudy or milky. There's something else happening than the explanation that, oh, well, it's just the CO2 that we're exhaling, okay, that's turning the lime water milky. There's got to be something else happening.
Yeah, and we think it's the salt. We exhale a salt from our breath, and it's that salt that precipitates into solution, into the calcium hydroxide.
Yeah, that's our opinion at the moment.
Because it's white. You know, we're all familiar with things being white. Salts are always whites.
Sure.
Whereas carbon's black. How can something black turn something white?
Yeah, see,
it's crazy.
Yeah,
crazy.
Yeah. I mean, when you think about logically, carbon, carbon dioxide contains carbon and oxygen. Carbon doesn't mix with water.
Yeah, no,
it just doesn't. It's not soluble in water. So you think, well, how can carbon dioxide, this carbon, 2 parts oxygen, 1 part carbon, actually dissolve in water? How can it? Yeah. It just doesn't make sense.
Yeah. If it doesn't make sense, it's nonsense.
Yeah, if it doesn't make sense, there's obviously something wrong with the understanding that people have been given. So,
and we got another video just to demonstrate we can quickly show people the next one, which is just the migration.
Oh, here we go. Yeah, this one's got
migration of salts. What we're doing is we're going to put some potassium sulfate into a solution, into a test tube. We're going to put a bung in it with a tube going into some lime water. And then what we're going to do, we're going to heat up the potassium sulfate solution, and then the salt will migrate through the tube into the lime water. And will it turn it milky? This is the thing.
Yeah. So
this is you blowing through.
Yeah, I'm just blowing through lime water to show that it is lime water that we're using.
Turns milky.
Okay, hopefully, there you go. So I'll just quickly go through this. I mean, so we've got potassium sulfate, which is a salt. We're going to put some into this test tube there. We're going to add some water, which is somewhere along there. We're going to add some water. We've got a bung. There we go. Shake it up.
And that's just regular water. That's not lime water.
No, it's not. No, it's not lime water.
Okay.
The one next door, in the middle of the rack, is lime water.
Okay.
Okay. The one on the right is potassium sulfate solution.
Yep.
We just added some water into it. Okay. So this is what we're going to be heating up, and we'll just put the bung on with the tube in it. Which is there. There we go. So, come on, let's have it. So there's the bung. There's the tube. We can see it coming out the top of the bung. Yeah. Let's move it along. And there we go. I've got something to hold. And then we've put the end of the tube into the lime water. Okay. So what we're looking for is that once we start heating up the potassium sulfate solution, will the lime water turn milky? will something migrate from the potassium sulfate into the lime water to turn it milky? This is what we're essentially looking for.
Okay.
So we've got the burner going, and let's just move this forwards. Okay, heating it up quite well. Yeah.
You do notice that the potassium sulfate solution starts going. There's a tinge of yellow to it, which is sulfur.
Yeah, that's the sulfur. Yeah, because we try our hardest to not let it boil.
Yeah.
Otherwise, it will the liquid will actually go. We don't want water actually going through the pipe. We'd much rather have gaseous. Steam, if you can call it steam. So, but you can see that there at the back there, look straight away.
Yeah.
The lime water's turned milky.
So there's no carbon. No carbon.
There's no. Yeah, we haven't used any source of carbon. So there's the comparison there. So so it's clear that other things turn lime water milky.
And the lime water exhalation test is like one of the principal tests that are used to demonstrate to, say, budding chemists that this is our proof that we are exhaling carbon dioxide.
Yeah. In our view, what they're teaching people is just so wrong.
Yeah,
it is just so wrong, because we can demonstrate time and time again that the lime water test is to indicate the presence of a salt.
Yes. Okay.
Yeah, that's what we think the lime water test
you
does.
Notice that whenever they talk about CO2 with the body, when they talk about capnography and all this lot, all they're doing is looking at the pH levels.
Yeah, because
all they're doing.
We've come to the conclusion. Well, at the moment, obviously, we've come to the conclusion that CO2 isn't carbon dioxide as such. It's a salt acid gas.
Yeah. And your body is salt. In your body is salts and acids.
Yeah, basically, and you have to. It's all about pH. Whenever they measure CO2 with regard to the human body, all they're measuring is pH. There was I can't remember what it was, blood pressure test or something. Was it blood pressure test?
There's also those as well.
Blood pressure test. They're all based bicarbonates. They're all measuring pH of the blood, or the pH of the air, the exhaled breath that you've got. Blah 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 blah. And
so I think, you touched on in one of your questions about the implications. The thing is that in my view, it's quite clear that mainstream science and mainstream healthcare are giving people completely wrong information about, in certain circumstances, how the body works. Because we don't exhale CO2.
Yeah,
we don't absorb CO2. There's no CO2 in the body whatsoever.
Yeah, we would call it a salt acid gas that we exhale, for example.
Yeah, we would say that there's an interactions between salts and acids in the body, and it's those interactions that could possibly make us ill or make us better.
This has come up recently with the work of George Washington Carey and Dr. Schussler and the 12 mineral salts. Is this something you've looked into?
To be honest with you, we tend to stick with mainstream chemistry that we can
debunk.
As soon as you delve into the body, we can't cut ourselves open and take a bit of blood you know what I mean. So we try and tend to do things that are tangible. But you've probably heard of Joseph Black.
No.
Who discovered carbon dioxide,
fixed air,
or fixed air, as he called it. It was called fixed air because you reacted a salt with an acid, and you got fixed air.
You got salt acid gas.
You got something that you couldn't separate.
Yeah.
But someone's come along like Lavoisier and called it carbon dioxide for some unknown reason. But they all want to tie it into the understanding the world we live in. And carbon dioxide, because if you burn wood and put the gases through lime water, that will turn cloudy.
But you've got to bear in mind that the wood naturally contains acids, tannic acid,
And salts.
And salts. So
Yeah.
those acids and salts, when they're burning, will react together to form this salt acid gas, which mainstream calls CO2.
Yeah.
So you can understand it's all about perception in certain respects.
Well, it is and it isn't, because you've also got to talk about the whole thing about like homeostatic levels.
Oh, sure.
And like, what happens if you take in too much salt or too much acid to your body?
Yeah.
I don't know.
Yeah, sure.
Yeah.
But that's on a different. But I'm just saying with regard to carbon dioxide, it's all about perception. You can, if you want to look at it as carbon dioxide, then you can, you know. But if you want to look at it as a salt acid gas, there's no difference. But I think you understand it better.
You understand it better, but you also can, if you're looking at like health and the human body, you can understand the salt and acids
in relation
to how your body functions.
Yeah.
We're also told that we are carbon-based life. Are you guys challenging that assertion as well?
Well, where's the combustion?
Where's the combustion?
I love it.
So if you can burn people, so obviously as soon as you burn someone, there's carbon present. But this is why they call them hydrocarbons. You know, hydrocarbons because you can burn them.
You can burn them.
They'll produce carbon. You know, your fossil fuels. If you know,
but they're only hydrocarbons. Yeah, they're only hydrocarbons because when you release them, when you burn them, they produce carbon and they produce water.
Absolutely, of course.
Because water's in the hydrocarbon.
Absolutely, of course. Yeah. You know, you've got to
petrol. How much water is in petrol?
Yeah, there's quite a lot of water in petrol. We did watch. Some guy did a video on demonstrating how flammable all of these different fuels were: petrol, jet fuel, and all these other fuels, gasoline, and we're thinking, they all contain water, all of them, because they use water in order to help fractionally distill all of their crude oil. To get your products of naphtha, your petroleum, and all this kind of stuff.
Even your gas that you get at your gas stove, that will release when you burn your gas stove. When you ignite your gas in your gas stove and leave it on, you'll get water condensed on your walls.
Yeah, if it's cold or
because there's water that carries the gas along the pipe.
Yeah.
Or should I say steam?
Steam, yeah.
Superheated.
Superheated, that's retained under pressure.
Yeah.
So it's able to keep its state, as it were,
So therefore it's then
gaseous state.
So therefore it's then able to condense when it's released into a non-pressure.
No, absolutely, of course, it's able to condense, I mean, it all depends, I suppose it all depends how you want to perceive it, I mean.
Well, anyway, so should we is that all right for you guys?
Well, yes, and I feel like we could spend another 2 hours diving into so much of the other territories that you are exploring, and I don't want to take maybe we try to set aside a date to do this again and continue the conversation. I don't want to take up too much of your time. I think I do have a question that's not on the list that comes to mind before we start to wrap up, and that is, do you encounter chemists, trained chemists or quote unquote scientists who come across your work and go, yeah, spot on, guys, like you actually you're right. No one, I've never looked at this, or no one's ever challenged these foundations, and these guys happen to be onto something.
Well, we do have subscribers on our channel who have got masters in chemistry.
We've got, as far as we're aware, we do have professional people on our channel who are subscribers who do hold positions where they would be, what's the word? They wouldn't adopt our views.
No.
Not absolutely, of course, but
And we do have, lots of people who think the Earth is a spinning ball, and they come knowledgeable people who have worked in air separation plants.
Air separation plants. Yeah, we've had people, scuba divers as well, when we've been
divers,
talking about diving and oxygen in the tanks. We
have all these people
blah,
who
blah.
come on our channel, we get into conversations with them. I mean, we've got a diagram of an air separation plant. We've got a brochure. I don't know if you want to have a look at that, because we can quite easily go into that and explain to you guys why we think they're not an air separation plant does not separate
air,
oxygen and nitrogen.
Well, it doesn't separate air.
Well, it doesn't separate air. Yeah.
Sure.
It's
up to you.
When you say a scuba diver, you're talking about an astronaut doing a spacewalk, correct?
Oh well, yeah. Oh, I know what you mean. No.
Oh well, yeah. Someone in the
pool.
In the pool,
yeah. Correct. Yeah. The ISS pool.
Oh, yeah.
We haven't done a lot of like space stuff for a long time. I did see a Dave McKeegan video about debunking that the ISS is in water.
Oh, right, okay.
And I'm thinking, but they only do parts of it.
Yeah, they don't do the whole lot, do they? I mean, it's it's a strange world we live in.
But yeah, we can show you one quick video about electricity, though.
Would you like to see it?
Let's please. Yes. Okay. So one of the things you said. Yeah. So apparently, water does not conduct electricity.
Oh,
water doesn't conduct electricity.
On our channel.
Oh, you want to go? Oh, yeah. Okay, yeah. Oh, yeah. Of course. Yeah.
There we go.
Yeah, this is one of our main. We've got a list of super cool videos in one of our. And this is by Plasma Channel. This one, using water as an electrical insulator, and he's got this guy. He's got this guy on his video. Yeah. He shows this guy here. Now he's put distilled water in this container, and inside the container he's got a hairdryer plugged into an electrical supply. He's got a light bulb plugged into an electrical supply. He's got something else. Now he's putting his hands in. He's pulling apart the components, the hairdryer. He's switched on the hairdryer. Yeah. He's doing all of this stuff. I think we see more of it. Yeah, there he goes. He's doing all of this stuff because the water is clean. It's distilled water.
Right.
Now, a lot of people think that water is a poor conductor of electricity. They won't say that it doesn't conduct electricity. They just say it's a poor conductor. Whereas, I look at this guy playing around with his stuff in that tray there, and I'm thinking, it doesn't conduct electricity at all. It can't conduct electricity. I mean, look, it's using mains.
Yeah.
So what the understanding we've come to, that we've arrived at, is we don't need to show the other one, do we?
No, that's it.
That's it. Yeah, I can. The understanding we've arrived at is that water doesn't conduct electricity at all. It's just the impurities contained in the water that do. So if you return to your electrolysis setup, you need to add, if you fill up your electrolytic cell with distilled water, deionized water, or very, very clean water, you won't get any conductivity at all. Okay, no electrolysis will happen. But as soon as you start adding your impurities, your salts or your acid, hydrochloric acid, your sulfuric acid, or your sodium chloride, or whatever, that's when you'll start seeing bubbles starting to come off, because it's those impurities that are conducting the electricity between the electrodes.
Yeah.
Okay, and
not
that's
the water.
Not the water. The water's not conducting it at all.
So you can, by all means, if you're going to have a bath in distilled water, bung in the toaster.
Absolutely, yeah. It seems pretty reasonable to do.
In dirty water.
In water that's got any impurities in it.
Even water from your tap or your faucet, your mains water supply, that has impurities in it.
Yeah, I know.
Has fluorides, has minerals in it, has things that will conduct electricity.
Yeah.
But it's not the water that's conducting the electricity, it's those impurities.
Yeah, sure. So you know,
and it's always been a misnomer. You know, people think, oh, water conducts electricity, but it doesn't.
Yeah, it doesn't. You know,
it's what's in the water that does.
Yeah, sure. So
yeah,
so that's that.
I think that and that's a beautiful, that for me is a beautiful entry point for myself, and I think for the listener, to the work that you're doing, because this is an easy one that you demonstrate, and yet it is, again, one of these quote unquote truths that we've been taught at a young age, an idea that just turns out to be, well, there's a lot more nuance there.
Yeah.
Well, Pete and Peter, listen, again, we could, I feel like we could do a couple hours of this, and I hope that maybe somewhere down the road we can come back on and explore some more topics.
Yeah, we'd be more than happy to come along. We've enjoyed it tonight. It's been good. Yeah,
it's been really good. Because we have lots of demonstrations and lots of other demonstrations. We can share lots of information.
You can.
About the air separation, understanding how man separates air.
Well, how he makes oxygen and how he makes nitrogen, for example, how he makes argon. But obviously for another time.
But we also think there's no oxygen in the air.
So there we go. So okay, that's our cliffhanger for the part 2. There's no oxygen in the air. Let me for the listener to learn more about you two and discover your work, where's the best place to go?
Best place to go would obviously be our YouTube channel, which is, I'll just get it up here. Our YouTube channel, there we go.
They can even drop a comment and say hi.
Yeah, absolutely. Yeah, more
we're a friendly bunch of people.
Yeah, we don't want to get too popular, do we?
Oh, right, yeah.
No, but we think it's quality, not quantity.
Yeah,
that's why we don't ask people to subscribe or all that kind of stuff. We just, we're easy going, we just, if people want to watch and subscribe, it's down to them,
Yeah, because one thing we haven't touched on at all, and that is our understanding that because our channel's developed over 8 years nearly, and our understanding of the channel and society and life and people has changed, we've kind of come to the conclusion that a lot of people are mad.
Yeah,
mad.
When you talk, if you're a flat earther and you're talking to a globy, you've got to be questioning their mental health. It's just the way that you are because of the views that you have.
Well, I could guarantee that they're doing the same thing to you, but I think the word and the
absolutely,
word
of course, yeah.
But the word that you use is delusional. And I love that, because one of the guests that we brought on back, in the early days, and we've had him on again, is Tom Cowan. And he talks about delusion as being a cause of illness, because if you don't know how the world works, you don't know how the body works, you're going to behave in a way that's going to be detrimental to your body.
Yeah, because the thing is that the more that you're deluded and you're fooling yourself,
the iller you are
about your own reality.
Yeah, the iller you become.
You become.
Yeah, because one of the things I've got to say this, I suppose, and that is, when you are true to yourself and you're true to others, that's when you're healthiest. Yeah, is it not? You could argue that. So.
Yep. Okay. Well, listen, we'll get you on again.
That would be great. Yeah, I mean, we're very because we do talk a lot about life and people.
Yeah, of course, but I don't want to talk too much.
To add a bit of that.
Sure, well. Not too much, though, obviously. Okay. But anyway, thanks, Ben, for having us on. It's been really good.
Yeah, Peter and Pete, thank you very much for coming on the Terrain Theory podcast. All right, ladies and gentlemen, welcome back to the after party in the Pineal Room. Dr. Miranda, good to see your face again.
It's been longer than usual, Ben. It's good to be back in the Pineal Room. I feel my being is better for it.
Come home. You've come home to the Pineal Room.
That's it. That's what I was trying to say.
As have you, listener. And well, listen, we offered no explanation. Mike and I took a week off from publishing the podcast, didn't we?
It's funny. The only other time we did that was, around the winter holidays, the Christmas, New Year's stretch. And then here we are 6 months later. Maybe this is our new normal, the 4th of July holiday.
Everyone needs a vacation.
Yep.
Even the podcast, and where you and I are just DIYing this entire thing.
Yeah.
We're not outsourcing it to editors and
No,
our
no.
team yet.
We make the rules. But all these are. It's not like it doesn't really feel like a vacation. Just life gets busy around these times. These are like the cultural overlays that we all, like it or not all of us, but many of us almost sort of get swept up in, right? Just the freneticness of these seasons.
Yeah.
We are no exception. We get swept up in it too.
No, no, but there is a that sense of guilt that I feel stepping away, even for a week. Like
Yes.
you get on this cadence and you feel the expectation of the listener.
Yeah.
I don't know, and the thing is, I feel compelled to apologize, but I'm not going to apologize because you were visiting family, and I was on a river retreat for 4 days, communing with the water.
Was that
Which
just you yourself in the
no,
water?
I went with a couple of friends of mine. Colin, who you know,
Yeah.
and then my buddy Bob. Bob, actually, shout out to Bob. Bob is a devoted listener to
Right
this
on.
podcast, and he was the one who connected us with Rob Williams, Dr. Rob Williams, because
Amazing.
Dr. Rob Williams went to his place of work, which is a really, really well-known brewery in Vermont, and Dr. Rob did some breathing stuff for all the employees at that brewery, and that's where. Yeah. So anyway, Bob mentioned.
Got
I
it.
think Bob mentioned us, and then we connected. So
Love
shout
it.
out to Bob, because Bob's been reminding me with every episode that Rob appears on. He goes, and I noticed no shout out to me, no credit given. So Bob, here's your credit. If you actually do listen to the podcast, you will now receive.
I'll
the full
alley-oop
credit.
that. Shout out to you, Bob. I've never met you, but I'm so grateful for our relationship with Rob Williams. So thank you,
Yeah.
Bob.
Yeah. So we try to do these river trips on the Connecticut, and we paddle and camp out, have amazing meals. Both those guys are hardcore foodies.
Yeah.
And also really deep into the beer, like craft beer scene, and not in the way that a lot of people dive in. Like they are just in it, like tip of the spear, and really embrace food culture. We had some awesome conversations about food in this region, trying to elevate food in this region, and commenting. There's an interesting point that came up in conversation, that when a person in a given town, particularly up here in the northern areas of Vermont or New Hampshire, think they're supporting like this mom and pop restaurant, like the pub downtown, and think that they're just, all that food is coming from Cisco, like one main food supplier. And no matter which little mom and pop pub you go to in any given town, like they're all getting the same food from Cisco, and it's all really like cheap, processed, crappy food. And we're just having this conversation about how do we better connect these restaurants, these small restaurants, which are like the favorite restaurant of everyone in town, to local food producers, even though it might be a little bit more expensive. Convince the customer that it's worth paying a little bit more to keep your food dollars within the community. Like really try to keep food dollars within the community. So we had some awesome conversations about that, and tying it to like wellness and stuff. So we've actually, some ideas are percolating, which I'm not going to share here because they'd be mad at me, but pretty exciting. Anyway, they're deep in the food scene, and we have like incredible meals on that fire on the banks of the Connecticut. It's a good time. And you were on the water too.
I was on the water on the New Hampshire Maine border with my folks at their beautiful lake house. Yeah, we had the 4th of July stretch up there with the kids and getting pulled behind the motorboat and the whole 9 yards.
Did anyone get flung?
Oh yes. That's
like
sort
the
of,
goal.
That's sort of what you're in it for.
Yeah. And both your kids are at a great age for tubing, where you really can start to torque on it.
You know what's funny though? This is true. This fellow, me, is not at a great age for tubing, and I mean, I do it. They don't want to do it without me. I think they like the ballast and the weight that an adult provides, because they're both little. I mean, Willie's 15, but he's skinny as a rail, and Opal's 11, and so it's almost like it's obligatory that Dad is on there too. So it's a lot, but it's still fun.
But you're not injured. You didn't get hurt.
No, I don't feel
despite the
like
opportunity to be hurt.
Yeah, there's some definite whiplash risk, and the tube isn't so perilous. It's the I remember when we were doing kneeboarding and like water skiing, like holding onto that rope for
Yeah.
10, 20, 30 minutes at a time. It was definitely fatiguing on the hands.
Yeah.
It's yeah, I can't wait for the goddamn hockey rink to open back up, because that's what I realized. That's where I get my fix. That's where I get my exercise. That's where
Yeah.
I can't get enough, and I feel like it's not gratuitous physical assertion. It's enjoyment. Whereas the tube, I'm sort of taking one for the team.
Got it.
But what the
Um,
fuck? It's a blast. It's a blast. It's just great to see the folks and be by the lake. Just to wake up by the water every day is a blessing.
it's a blessing, isn't it? It's
Yeah.
magical.
Yeah.
And fireworks.
Fireworks were almost. It was a weird year, Ben. Because the 4th fell on a Tuesday, coupled with the fact that there was a lot of rain over the stretch of days, there was sort
Mhm.
of some miscommunication about when in a normal year you get out on the boat on the lake, and they literally, a couple households sort of take the responsibility to host the firework celebration, and they just like sort of redneck style just go nuts, just shooting them right above your heads, and it's sort of gnarly. You're sitting in a cloud of smoke
Right.
on a boat with dozens of other people hooting and hollering, and it's fun. um this year, though, someone made the executive decision to fire off the fireworks on Sunday night. I guess thinking like it's the end of the weekend, when
Yeah.
it had rained all day. No one wanted to be outside. No one wanted to be on their boat. It was even raining that night. Um, and then there was this sort of assumption amongst the community, like, okay, well, this is the 4th of July Tuesday, and it was a beautiful day. And so everyone's out there in their boats, sort of milling about, floating around, waiting for the big show, and it had already
It
happened.
already happened.
So there was this weird, like, anticlimactic, sort of awkward communication schism that occurred, and I couldn't help but see it as like a microcosm for America as a whole.
Just
Just not like
big misses.
big
Big
misses, like
misses.
wanting to celebrate, but everyone just not being on the same page. And
Yeah.
yeah,
I did not see a single firework this year, and I
good for
didn't
you.
miss it.
Yeah.
I didn't miss it. In fact, we were gonna host there was a parade that was happening in the town over, and the school that Grayson goes to was invited to be a part of it. We were gonna do the parade. We were gonna host a barbecue here, and
Yep.
the weather just looked like absolute crap. So
Yep.
we canceled all that stuff when we drove to Vermont, where Michaela's family is, and her sister was up in town from Texas, and the cousins were all there. But missed all the fireworks. I bought a bunch of hot dogs for this cookout I was gonna have, and I spent 20 minutes at the co-op in Littleton debating whether or not I get like the quote unquote healthy hot dogs, which are like $5 a pack more for fewer hot dogs. And I said, you know what? F it. It's once a year.
Yeah.
Got
Yeah.
the Fenway ballpark, whatever, Frank's,
Yeah.
the crappy rolls. And I rolled up and I had a Sharpie. I was going to redact all the ingredients. Like, because it's a very discerning crowd. And sure enough, like first thing everyone did was like reading the ingredients on the hot dogs. Like, guys, it's once a year. No one's going to die eating a
Amazing.
Fenway ballpark Frank. So my contribution
Redacted.
to the party,
Redacted.
redacted ingredients. First thing on there, like high fructose corn syrup, seed oil, classic. But
Yep.
I'm starting to come back the other way. Like cut out 99% of that. Awesome, but man, if you're gonna obsess about every little thing, I don't know. Maybe that's just me. I like a hot dog at the 4th of July. That's the only thing. That's the tradition I might carry through. Maybe I won't. It was really interesting, Mike, coming off of our Pork Fest appearance, the conversation we had with Tim about what it is to be a citizen of the US, like all those conversations, and then going right into the 4th of July and feeling
Right.
like I'll still, put my fist out the window of the truck when I see a truck flying by with the American flags, because I kind of know where they're coming from. Like I get it. Like I get the spirit that they're trying to invoke. But at the same time, I did not feel it as much this year. In fact, it felt like the absence of fireworks were completely aligned with the just that diminished sense of patriotism, because I guess I just no longer look at America as this like great shining example of freedom. When you really start to, as you are, like we're diving in, Tim's diving in, we're diving in and we're going, man, taxes, it's organized crime.
Allegiance to a corporation.
Yeah, yeah.
It seems weird. Patriotism versus pride. Even I've been listening to a lot of Utah Phillips because I go back with his wisdom, and he was
Mm,
a proud, outspoken anarchist, and he spoke pretty eloquently about it. And one line that always rung in my ear was, loyalty to the country, always loyalty to the government when they deserve it.
yeah,
And that sums it up pretty beautifully. It's like you can that's you we're so quick to point fingers and tar each other with this, that, or the other brush, but it's like we grew up on this land in this place with these people. We'll always feel a sense of pride and loyalty to where we come from.
sure.
But all of the bureaucratic entanglements, that's not what you think about when you're a kid, or like that's not something you're proud of. There is the whole, like, there's the marketing push of the patriotic stars and bars, and, like, of course, the pageantry of the fourth, but it's starting to feel more like an ad campaign and a spectacle than something that has any sort of like roots.
Yeah. Yeah.
Finding the true roots is I
Finding
think
the
what we're
true
doing.
roots.
Yeah.
Yeah. And it's really just comes down to community, doesn't it? And then the
Yes.
the one thing we were sold on about America is like land of the free, home of the brave. Well, I can look
Yes.
around and
Yes.
I can embrace that, and I can embrace everyone's desire to be free and what I've seen as examples of true bravery. Um, for better or for worse, for right or wrong. But I don't look at the government. I guess I've just divorced the people, the American people, the people I love, my neighbors, my community members, from the government, which I just no longer feel acts in our best interest.
Or
Doesn't
speaks in our
represent,
name. Yeah.
yeah, it just doesn't represent me. Doesn't represent anything that I stand for.
Yeah, and
Um,
I
you
mean,
know,
not to belabor this, but this whole idea. I mean, how many compatriots, to use that word, over the years? When a war starts, and like, well, not in my name, or I don't want that blood on my hands.
yeah,
And you can take that same line of thinking to like the billions of dollars, our money that get poured into the pharmaceutical industry, the vaccine industry,
yep,
the, we've talked about this ad nauseum, the medical industrial complex. It's like the rubber has really met the road. That it is in our name, and it is right out of our pocket.
right,
And so we've got to figure out ways to starve the beast.
yeah. Here, here, extraction. Time to
Yeah.
extract.
I we haven't
And
we haven't seen each other in a minute, so we've got a lot to catch up on. But it's funny, we mentioned like it was sort of a how has your thinking changed on the weather? Right, the Fourth of
well,
July, and
okay.
it was like a shit
I
show of
laugh.
rain, and it was coming right out of like
Yeah.
the crazy smoke screens of
Well, I laugh, but I guess it's a nervous laughter. Vermont, where we moved from recently, the town down the road from us. So I lived in Huntington, and Richmond, where I get groceries, like go mountain biking. It's completely underwater. It's just completely
Richmond is.
underwater. Richmond is, yeah. I mean,
Yeah,
much of that downtown is underwater. Like you can't. I don't believe you can drive through on that main street right now. Montpelier, the capital, Main Street is just underwater. I think probably many of those establishments now have just standing water in their establishments. You've got towns being evacuated. You've got towns cut off. It feels like Irene all over again for Vermont. And I believe you had
same thing in
some towns in,
the lower Hudson Valley. Yeah, I'm
yeah.
getting a lot of texts from friends reaching out asking how we are. Luckily, we
Yep.
are a-okay. But okay, so continue.
Yeah, well, we've had conversations now about weather modification and geoengineering, and it's there's no smoking gun. We don't we don't we don't have the ability. Even like citizen scientists don't have the ability to point the finger and go, it was this and this and this. And the narrative is always going to be that this is like the new normal, and we have to act on climate change, or we're all going to drown. It's just going to be worse. And obviously the cynic in us goes, well, yeah, this is being created. You have the capability to create rain. We know that there's the capability of creating rain. This is what was done over the Ho Chi Minh Trail. We were causing it to rain over the Ho Chi Minh Trail to bog down the VC, so they couldn't. Their supply line was bogged down and slowed and halted. That was back in the Vietnam War. So we know we can create rain. Is that what this is? It's just impossible. It's impossible to answer definitively one way or another. So I will always say maybe. I'll always say maybe. And also, I wouldn't be surprised, because it is the lever of control that is being pulled right now. And it will have us, because people are in this situation, they're being evacuated, their lives are at risk, their livelihoods are at risk, their homes are at risk. You will create the situation where the people are begging
Yeah.
for more control, control exerted over them to prevent this kind of thing from happening. So it's a wonderful, perfect lever to be pulling, and they're fully capable. I don't doubt at all that they're fully capable. Whoever has access to these technologies, fully capable of making this thing happen.
Yeah.
So
Problem, reaction, solution, pandemonium. Like you said,
yeah.
get people begging for action,
Yep.
more
Yep.
top-down action.
Control me. No wood stoves, no wood-fired pizza, whatever it takes. Please make this stop. Whatever it takes. Mommy, daddy, government.
Yep.
We're helpless. Please make this stop.
Yeah.
And meanwhile, we're ringing the alarm bell, pointing up at the sky and going, there it is. Like, let's start there. Ground those planes and let's see what happens.
It's just,
Maybe we won't have a 1 in 1,000-year storm ever again.
Yeah.
Maybe.
Yeah.
So I don't know. And in the state of fear that people are in right now in these areas, they're not going to look at that.
No.
They're not ready to look at, wait, this was caused by the very people I'm asking to save us or claim can save us.
Yeah. This was an attack.
Yeah, maybe. I don't. God, it sounds so conspiratorial, but at the same time, it's completely in line with what we seem to know is possible and is happening. So yeah, question everything, I guess. And man, no guests better embody the spirit of questioning everything than Peter and Pete, which we haven't even touched on because we've had some catching up to do. And I got to say, to the folks out there. So we had a listener reach out via email a little ways back and say, have you checked out Peter and Pete? You got to download their ebook, 100 Reasons Why Water is Not H2O. Like, think about having them on. So reached out. I mean, I checked out their YouTube channel, and going after the fundamentals of chemistry, what we were taught in high school. I just haven't met anyone doing that. I've not encountered in these conversations around terrain and germ theory and virology and taking that down, not met anyone who's saying, okay, let's do the same thing to chemistry. Let's do the same thing to what is the atmosphere. Is it really, oxygen? Let's do the same thing to what we exhale. Is it carbon dioxide? Let's do the same thing to water. Is it really H2O? How do we know these things? And so having them on, I just want to say to the listener, having Peter and Pete on does not mean that Mike and I subscribe to what they're saying, because I don't know enough about it. And quite frankly, chemistry was a long time ago for me. So, there's some things that you remember, some things that you don't. And so all of this is taken with a grain of salt, but I appreciate anyone willing to go there. I appreciate anyone who's like, well, let's trust but verify. And they also have the equipment, basically the science experiment equipment, to conduct these things and to conduct some of these experiments and hold it up and see if it stands up under scrutiny. And it appears, according to them, that some of it does not. So why not is my follow-up. Okay, why not? Let's go after chemistry. If virology is crap, and that really underpins everything, that, like, our entire world that we all exist in, germ theory, we're brought up in the germ theory paradigm. It is just part of your worldview. And if we're going to look at that and say, like, actually, that's wrong, and that shatters your worldview, and now you've got to build it some other way. Well, I mean, let's not build it upon these other foundations that also happen to be incorrect. Like, let's analyze all of it. So thank you, Peter and Pete. I still don't know if you're like 100% authentic or if it's all a bit, because their banter, it sort of feels like, wait a minute, am I being like punked here? But who knows?
Even the
I'm gonna
name,
give them
as we said before we rolled tape, it's like Peter and Pete. It sounds like the Smothers Brothers or something.
yeah, but I'm gonna give them the benefit of the doubt. I mean, they reached out right after the first episode wrapped, and they're like, we had a great time, like, let us know how we get on again so we can do a part 2, because I want to do a part 2. I really want to dive into some of the other things they're exploring, and I'm going to give them the benefit of the doubt. I'm not going to go into it thinking that we're sort of being we're the butt end of a really long game elaborate parody channel. I don't know. We'll
I
find
know.
out.
Well,
Who
they
knows?
do have some naysayers, as you said. If you read some of the reviews of their books, there's people who are sort of calling bullshit.
Yeah.
But that's not what we're doing. But it is. I
No.
think it is fair to not just necessarily dive in headfirst to the next shiny thing. But like you said, virology, it seems more and more clear, is just the the wing of medicine purely under the pharmaceutical umbrella. Like, it's sort of the pharmaceuticals. It only exists under a pharmaceutical paradigm. It
Yeah.
doesn't exist without that.
Yeah.
They are part and parcel of the same thing. We have Cowan talking about the new biology. Do we really understand cell biology? Do we really understand what organs are made of? Do we really understand what our bodies are made of? And so
DNA.
DNA. So why not apply the same
Yeah.
set of critical thinking to all the scientific disciplines? Absolutely. I mean, I
Yeah.
love that it boils down to really this beautiful sort of, I don't know what word to use. I don't know if it's like holistic or esoteric or like old world. This, like, the 4 basic elements of fire, water, earth, and air,
Yeah.
and that they are enough in and of themselves. Like, what did they say? So when you said, so what is water? Couldn't tell you. Couldn't tell you. What is fire? Maybe it's the same thing. Couldn't tell you. What is
Mhm.
air? Couldn't
Mhm.
tell you.
Yeah,
It's actually, there's a beauty in that simplicity, right?
I think you're right. Yeah. And yet science wants to, it's constantly just wanting to pick apart. It wants to take this thing and pick it apart and dissect it and tear it down into all its little fundamental parts and try to explain it. And I think science, I think there are those in science and those conducting science who are funded. Like, much of the science that's done is expensive. It requires money. And so you feel an obligation to provide an answer, to provide that answer. And I think when you introduce money, and so a person's livelihood is, if I'm like a research scientist, my paycheck comes from this funding, and I am obligated to provide an answer. And so therefore you do. When you have money, it's like money in medicine too. You go in as a patient to a doctor, whether it's naturopath or otherwise, they have an obligation to provide you with an answer. This is what it is. And they will feel like, one, that they're not going to get their money's worth from you if they say, go do a 21-day fast and you'll be cured. That's not how that works. Or
No.
I don't know. I don't know. Yeah, I don't know. You tell me. What do you think it is? Wait a minute. What? I came here for answers.
Yeah.
You don't. When money is intertwined in science, when money is intertwined in health, like, I don't think you get pure answers. I think it's right. I just don't think you get pure science 100%
What's
of the
funny
time.
too is, like, if you look, there's the irony, I guess. I don't think it's irony, but I'm going to just use that word because that's what people do. There's no shortage of information. Like, and I'm not even talking about the internet. I'm just talking about, like, books. Like, I have piles and piles and piles and piles. Like, just you, I'm looking at you. You got your bookshelves. They're filled with books. My books are spilling out onto the floor. Um, it's When you look at it through that lens, it's not like the best information has bubbled to the top. It's a carefully curated uh, information stream that has been allowed at the top levels. And perhaps as it comes out my mouth, I'm stating the obvious, but the avail yourself of data. There's no shortage of different opinions out there. That's what's interesting, and that's why you have to tip your hat to the people who don't have the big publishing deal, who don't have any grants, but they're still cranking out this information. The citizen scientists, the investigative reporters, and they're publishing. Like people like the Baileys, they're doing the work. They're getting the books to the people. Dissolving Illusions, uh, The End of Germ Theory, all of it. It's these books do exist for you to. I've had to sort of. I sometimes you listen to someone talk, you buy the book, and you don't necessarily read it right away. But I've been diving back into these books. I've been so grateful that they're in my home. Right, these books are in my home, and I can reference them and share them when I need to. Um, it's just it's not that it's a big world, but there's a lot of people doing the necessary work to broaden the conversation, and our job is to champion those voices and to really understand what these people are saying.
Yeah, and just respect the folks who are questioning everything.
Yeah.
Who are taking the time to question everything. I just can't discount anyone anymore.
Yeah.
I won't. I can't discount anyone like out of hand. I'm just gonna hear them out. Well,
Well,
maybe. Okay.
the
Well,
whole
maybe.
thread of these modern times is that the uh the dogma is disintegrating before our eyes. It's just very it's people are a little slow to catch on, but that's what it really feels like is happening.
Mm.
Would you agree with that?
I
Or has it
suppose.
always been this way? Has it
No, no,
always been
no.
this tension
I.
between?
Oof. That's a great question. I don't think so. I think because of social media and our ability to connect with people across the world instantly, so access to a Sam Bailey and a Mark Bailey and what they have to share, like that was not possible before the internet and before platforms, before YouTube, or since they're censored there, before Odyssey or Rumble. So I don't know. Maybe there were people who were having these conversations around campfires, but it's certainly the movement was not able to grow as it has. I mean, look at what Etienne de la Boussie is doing and this movement towards voluntarism. That's not possible without some internet. Although he's going to do grassroots, but the people who are aware of it, who are willing to support him, I don't I don't remember hearing anything about that back in our 20s. I don't remember hearing a whisper of anything like that politically.
No, like I said, for me it was relegated to like old hobos like Utah Phillips,
Yeah.
fringe folk singers who literally are around like sharing ideas around barrel fires and train yards. I'm not
Right.
even like romanticizing it. That was like
No, no, yeah.
that, that was his life, and it's like, okay, well, I love Utah. He's a poet and he's intellectual, and I love these ideas. But it did seem relegated to old, dusty ideas that smart, bearded guys sort of fantasize slash preach about. But who would actually do that?
Right. Yeah. Oh, think about just podcasts. The ability for anyone to create a platform and create an audience. So I think about like Alex Zek and the way forward and what he's trying to do with the way forward, both the podcast and the grassroots organization. Literally, like just charting that way forward, saying this system that we've all been raised in doesn't work. Let's create the new one. Here's some ideas that we can carry into it. And so that is a schism. That's a branching away. That didn't really happen in our lifetime, up until now. And I don't know, maybe the hippie movement, people like the 60s, there's obviously conversation that was all sort of engineered or orchestrated. I don't know. I mean, maybe it was. It certainly seemed from where we're standing now to have some authenticity to it.
Yeah.
Maybe it was also rather meaningless because it was really just dropping out and doing drugs. I don't know that anyone was really trying to create. I don't know. I don't know.
I
But
heard someone say recently, well, the Quinn in Ishmael, he called it the failed children's revolution of the 60s. And the reason it failed is
That's right.
because they failed to recognize the bars of the cage.
Yeah.
They were sort of like rattling the bars of the cage, but they couldn't actually
Yeah.
identify them. But I heard someone in an interview recently, he the idea of intentional community came up, and we hear that term bandied about a bit. He's like, I don't want to be in an intentional community. I want to be in an unintentional community, which which
It's
actually
cute.
sort of resonated with me. It's almost like where you live. You live in rural New Hampshire, and you've got your own little piece of land, and you know your neighbors. Some of them are farmers, some of them are plow people. It's like
Yeah.
that's just what community is.
Yeah.
None of you intentionally moved to Lancaster, but now that you're there, you're going to get to know each other and use each other as an unintentional community. And
Sure.
maybe it's a little less precious. It's a little less intellectual or something. I actually really resonated with me.
Yeah, well, it's not like you're not waking up every morning going, community, like, come on, let's go. And like that, rally everyone into this thing in this direction. It's like, no, actually, we just inherently know how to live like good neighbors.
Yeah.
And we're all collectively going to help each other in times of, trouble and hardship.
Yeah.
But it doesn't have to be this thing where we plan 8 hours a day. What's our community going to look like?
Yeah, and whose
And
job is it to
whiteboard
fix the
it and all that
tractor?
stuff. Yeah.
Right. That's exactly right. That's
Yeah.
exactly right. And it seems like less of an ask. It's like you don't necessarily need to uproot yourself. And again, that's the idea Quinn said in Beyond Civilization. What will it look like? It might look exactly the same. You might not have to go anywhere. It's just changing the way you relate to where you are.
Yep. Yeah, I mean, if you just cut off, if you said, okay, we're just going to cut ourselves off as a community from like central government, whatever that is, like the federal government, even like state government, we're just going to exist as a community, and we actually can have all of our needs met right here in this community. And we might trade or barter with other communities when there's things that we don't have or need, but like we don't need tax dollars. We don't need like big defense because we're not going to fight anybody. We're going to figure all that stuff out. It seems in your head anyway, when you do this thought experiment, like, yeah, it could actually work that way. We have these unnecessary ties to bigger and bigger government that's lord over us and take our money. But how much of that is actually necessary? I don't know. Like, we've got plumbers who can fix things. We have electricians who can fix things. I suppose to some extent, like the raw materials or the products that get used in the fixing of I mean, I think I always come back to like utilities, because there is something to be said for like your town has town water and town sewer, and those things break and need maintenance, and those require materials to do. And the equipment, the heavy equipment and machinery for farmer, like you do have to have, it seems, a connection to the outside world where some of those things get manufactured. But I don't know that you necessarily need mommy and daddy government in any capacity facilitating that relationship or the creation of those things and the sharing of those things. So I just, that thought experiment is like, wow, couldn't we just do this as a town and not need state government and not need federal government up in our business? It feels like it might work, but maybe it would also like crumble within a week. I don't know.
These are the big questions. We
Mhm.
don't know, but it's fun to talk about.
It's fun to
That's
talk about.
that's where we always trip up. It's like it's one thing to like, and it's always through this. It's probably because it's like programming from growing up with TV, but like you immediately go to this like homestead intentional community place of, "Oh, we're just going to be small and everyone's going to grow a different thing." But then you start asking the bigger questions. What about roads? What about plumbing? What about garbage? What about this? And that's where people tend to trip. Like, what happens about the bigger, I guess they call it infrastructure projects? How do those get accomplished? It's not that how they get accomplished. We know how they get accomplished. Like, people work hard and they build them. People do it, but it's the money structure. It's the corporate structure. How does that make sense in a way that seems fair and equitable when you're trying to decentralize and keep things small? Those are big projects, big ideas.
Yeah.
I don't
They have,
know.
I don't know either. I mean, the system has just become
Such a behemoth.
it's such a behemoth. It is this multi-tentacled uh, beast that's got its tentacles in every aspect of your existence, and trying to pull each one of them off of you, it's going to be painful. There
Yeah.
are going to be there are going to be times of pain. If anyone does this, there will be some pain, there will be some hardships, there will be sacrifices, or what appears to be sacrifices. Like you think about, okay, if a town existed on its own, like just dealing with trash and garbage, I think that you would realize very quickly, as a town, like we cannot have trash. We can't have plastic stuff. There could just be no plastic trash or plastic stuff. And then you'd realize like probably most of the plastic stuff is unnecessary. If you just come back to your basic needs, like food, water, shelter, clothing, you don't need as much plastic as we produce or use in our lives. And so you pull that away, and I think your life becomes very simple.
Yep. The
Yep.
problem is the solution.
The problem is the solution. So think about like my kid, raising my kid, and all the plastic that is in his life, the toys and the crap. And if you
Every
took that
meal.
every meal, I think it'd be wonderful to remove all of that, to find a way to remove all of that. So now all you're left with really is stuff that can compost,
That's it.
stuff that can biodegrade and compost or just be reused,
Or
which
be
is,
reused. Yeah.
yeah. Yeah. I mean, plastic is just needs to go.
It's so funny how we know this so intimately. There's a great sign that Pete Seeger used to post, like, if it can't be reused, recycled, repurposed, it should be removed from
Yeah.
from society. And we all read that and it resonates. We go, yeah, it should, and nothing changes.
Nothing
We don't
changes.
know how to extricate ourselves from this behemoth. We
Yeah.
just don't on the day to day. We can wax poetic and have podcast conversations about it and speak about it ad nauseum. It's very hard to extricate. That's what we keep coming up against.
So, okay, so if you go back to Quinn and his analysis of the failed revolution of the 60s, that they were not able to find the bars of the cage, do you, Michael, Dr. Miranda, feel like you've found the bars of the cage? Like, have we found the bars of the cage?
Right. And beyond a philosophical place.
Even philosophically, do we feel that we know where the bars of the cage are? I mean, just by reading Ishmael, wasn't
What I'm
that?
starting to realize, sure. I mean, I'm starting to really come around to this idea that the bars of the cage are literally, we talked about it in an earlier conversation when we said, like, keep moving the goalposts out, and you said no goalposts at all.
Yeah.
No goalposts. That's that Overton window thing. I think the bars of the cage are the things that we're allowed to perceive as acceptable.
Mm.
Because Quinn said there's more than one way to live. That was like one of his mantras.
Mm-hmm.
And I think as like modern American men who love to explore and pull the thread, we're still confined by that Overton window. But what the ways that we are allowed to perceive our lives unfurling with the entanglements of friends and family and community, right? We're still sort of shackled to the predominant systems. As much as we like to poke holes with them, in them, and start our gardens and our bees and start to produce a little bit for ourselves, I think we're still very, very hemmed into that Overton window of how big we're allowed to dream.
I love that.
I
So
think the bars of the cage are more. It's more of a mental construct.
mental. Yeah, interesting. Well, I like that. We're closer. We're closer to discovering them. Well done. I'm glad I asked that question of you.
Well, what about you? I'll flip it on you.
I don't know. I think that the point of Ishmael and his subsequent books were to show us the bars of the cage. So totalitarian agriculture. Those were the bars that he was really focusing on, wasn't it?
Yeah.
Is overproducing food and then locking it up.
Yeah.
So that is always in my mind as we grow gardens and have bees and chickens and things like that, is always food, food sovereignty, which is a phrase that's thrown out there. But a return to a place where individual families and then communities are growing all their food, are growing and raising all the food that they need, and are no longer dependent on like the big ag factory food and things like that. So I think because that's one of the fundamental needs that must be met is food.
Yeah.
And water. I guess this is, the guys like Matt Roski and the primary water organizations are trying to inform folks of the truth about abundance of water, that there is no water scarcity, that water is forever, and there's way more than we're told that there is. So you get that need met. Those are the bars of the cage. For me, I'm answering, like, the bars of the cage are perhaps this scarcity myth.
Yeah, that's a big one. That's
Yeah.
beautifully reminded. Thank you for reminding me of that. It all comes down to this what is the word? It's a manufactured scarcity, I think, is
Manufactured scarcity.
what we are discovering across, whether that's our currency or whether it's food and water, electricity. It's a manufactured scarcity,
Yeah.
and that also plays into even be able to have this conversation and ask who, what, where, when, why, how long this game is being run. That's it. So let's get back to Peter and Pete for a second. It's like,
Yeah.
because they're saying, they talked about like the hydrogen is not extracted from water, and some of these people who do, like, because I've listened to a lot of conversation with people like the Brown's gas machine, the hydrogen gas machine, people who breathe hydrogen therapy. They were making the claim that yes, at the other end of the pipe there's hydrogen produced, but it's something that's been extracted from the equipment and not so much the water. And so, like, so what does that say about like the water engine automobile that we've both like looked into a little bit or seem to be cognizant of? Is it still a valid technology? It's just the hydrogen isn't coming from where we think it's coming from, and that over time the engine itself is the thing that's providing the fuel and will over time disintegrate, and that the water is actually the water is never going anywhere.
And not transforming or anything.
Yeah.
Yeah. Yeah.
It's just, what is it then? It's the medium through which the electricity it's the, what do they call it? The flow or the pathway or the channel. Fucking wild.
It's
It changes your like the way that you and I would like bandy about this romantic notion of like the automobile car, the hydrogen engine. It's like it
because I have the
changed.
water engine. I don't even know what you would call it. What you would call it. And then my like freaking never ending capitalist mind goes, okay, what's the like RTG, the ready to go drink that plays off this? Like, not H2O water in a can, like let's subvert the like the bottled water, the like vintage water on the shelf. We'll call it not H2O. Like, what do you mean it's not H2O? Just fucking drink it, man. Just buy it and drink it. So Mike and I can expand our little kingdoms.
Couldn't tell you.
I gotta turn that brain off. But yes, I mean, I definitely was out on the river, floating in the Connecticut after the flood. So just raging current, just holding on for dear life, rethinking what it was that was, keeping me afloat and surging all around me. It's just water. It's just what is it? I don't even know. I'm not even sure, but I feel it.
And it's you too. It's not just the stuff you're floating in.
Right.
It's what it's within you.
Right.
It's within you, whatever this stuff is. Couldn't tell you.
But you come back. Okay. So okay. Pete and Peter can question, or Peter and Pete can question this like chemical composition of water, but I will fall back on what Veda Austin's doing and look at what appears to be an intelligence, a memory, a creativity, and go, okay, maybe we don't have like a scientific process that's breaking down exactly what's happening, but there is a mystery, beauty, and a magic there, and I can fall back on that as I'm bathing in the rushing waters of the Connecticut and go, there's like a magic and a beauty, and a like the seed of life is found right here, like surging all around me, and I'm happy, I'm content right now, going, this much I know. Water is intelligent. This much I know, like water is the source of life.
Yeah.
And I'm okay with that.
Here. That's beautiful.
Yeah.
I think it's important to, and maybe even necessary, to start to find ways to embrace the simplicity instead of just like banding about these heady ideas.
Yeah.
And that's essentially what they're doing. They're calling bullshit on complexity, overcomplicating things.
Yeah, overcomplicating things upon a foundation of bad science.
Yeah.
Which is what germ theory was.
Yeah.
Just creating complexity upon a foundation of sand.
And as we've said before,
unproven assumptions.
If you don't know what's actually real, you'll never truly be well.
And and look, we drew this comparison, and I think it warrants repeating that what a lot of their videos on their YouTube are calling out delusional thought, delusional thinking, which is exactly what Tom Cowan does.
Yeah.
Delusion. He focuses on this. That's one of the 4 main causes of illness. You are delusional. You are not seeing the world for what it really is. You're not even seeing reality for what it really is. And they're doing the same thing. So I see that overlap and I go, okay, that seems to be a touchstone or a common ground here. So
that's the Overton window. Yeah.
Maybe we're not being punked by really clever duo, comedy / parody.
I like that you're willing to or not willing, but that we're not just like falling backwards into every guest we have on, like hook, line, and sinker, that we keep it at an arm's length and be like, okay, that was fascinating, but let's not let's have some degree of skepticism.
Sure.
Well, but as you speak about
it's an hour Zoom. Like we're not gonna unravel all of chemistry in 1 hour.
Yeah. And but what you just said, it's like the scarcity mindset. It's relevant to that. It's that Overton window scarcity mindset thing. We have a scarcity of possibility that has been presented to us as modern people. And I think that's what we're learning, is that the scarcity mindset doesn't just apply to water, food, energy. It applies to our curiosity. So
yeah, the building blocks of the world around us.
Yeah,
that is they are going after the building blocks of everything that's around us
because they're curious
in us.
They're
That's
curious.
important. Yeah.
And and demystifying perception.
Right.
That's what the great thinkers are doing. They're expanding the bounds of acceptable thought. You've had too much to think is something that came across my feed recently that I thought was awesome.
You've had too much to think.
Yeah.
Well, Michael, I'd say we wrap it. This is a long after party. Listener, thanks for hanging on. We are going to get Peter and Pete back on for a part 2 because there's a lot more for them to explore. And again, we did that on Zoom because there were a lot of videos. So we'd encourage you to go check out the YouTube channel so you can see some of what they were doing. We'll put that up on our YouTube channel. It's the Terrain Theory YouTube channel. And maybe we'll get that up on, I think we're on BitChute too. I made an account for like all those alternative streaming platforms. Some of them have limitations on the size of the file, and I'm like, ugh, I don't want to compress. I don't have the time, Michael. We don't have the.
I know.
We haven't enlisted the necessary AI platforms to do all this work for us.
Right.
By the way, Buzzsprout, which is hosting this podcast, has a feature called AI co-host. So I'm just throwing that out there. Shots fired to you, dude. If you ever start slacking, there's an AI co-host. Don't think you're not replaceable, Michael.
Oh, God.
You will pull your weight.
It starts.
It's not an actual. It's like it just does some other features that are not actually co-host feature. Like it's not a fake voice or co-host that comes on the show that just does all this like side crap. Yeah. I've not enlisted it, but I did want to throw that out there just to keep you nervous and on your game.
I appreciate that. And before you wrap, folks, Ben and I were doing this a year and a half, and still just 100% labor of love, and we are bandying about ideas to potentially start some sort of fan-funded model, whether that be a Patreon or a locals or some way for you guys, because some of you have expressed ways to try and support this undertaking. And obviously we're not doing it for the money, but it would be nice if there was a little bit of a cushion there. So we'll try and keep you posted on what we're thinking. Or if you have ideas, feel free to float them our way as well.
There you are. And remember that nothing you heard here should be taken as medical advice, as neither Mike nor I are medical experts. And remember that you are light and you are love. Maybe you're H2O, but maybe not. Thanks for tuning in. I'll catch you on the next one.